Hey everybody, what's up? It's Zintail. I'm here to show you my spirography room and show you how this works. So basically the drawings you see around you are generated by gizmos and circuitry. They're spirographs, and I have two machines in here. There's a manual spirograph, which you can use, just for kind of playing with, or use it for like pattern discovery. And then there's a state machine programmable spirograph, which allows you to rapidly like iterate on things. Like you could say, oh, okay, I like this pattern, but I want to change the color, or I want to, make this bigger, make it smaller, higher frequency, that kind of stuff. So before we dig into using those machines, I just want to kind of show you how this machine works, because there is quite a bit of configuration that you can do with these two machines. Okay, so let's talk a little bit about how these machines work, right? So in the center of every machine, there is a rotator. Okay, and then that's the primary, and then there's the secondary rotator. And then over here is the right head. Okay, so the right head is where all the pens are, right? So basically the way this thing works is there's a bunch of pens on a rotator, and when you press the button on the manual one, or when you program the color in, on the programmable one, it switches the pen. The reason it does that is so you don't have to take out the maker pen and recolor it. That'd work fine on the manual one, but obviously not on the programmable one, right? You want to be able to say, I want to run the sequence and then have it paint this color, right? So there's the right head, and then between these are pistons. Okay, again, primary, secondary, right? So what these do is these control the distance between like the primary and the secondary, or the secondary and the right head. And what you can do using the buttons in the manual, or by programming it into the programmable, is you can set the function that controls the distance between those. So for example, you'll see on the board over there, so I'm not going to go through them all, but like 0 is like a static, a set amount of distance. So if I set this function, you'll see that as f of x to be 0, which is a straight line function, and I have the amplitude set at 20 for the primary, it means the distance between the primary rotator and the secondary rotator is always going to be 20 centimeters, right? Now, you can do other things, though, besides having it be static. If you set it to 1, for example, it will do a sine wave, which means the distance between the primary and the secondary will vary, okay? So you can get some really interesting patterns going with this kind of stuff. All kinds of things you can configure with this, right? Like I said, you can set the function on this amplitude. If it is like a cyclical function, like a sine wave, you can set frequency on that. You can also set the rotation speed on the primary and the secondary rotators, and then there's also something called smoothing factor, which is basically the speed that these pistons work at. So if you have that set at instant, it'll immediately get to the position it's supposed to, but your spirograph will come out choppy. If you set it to a higher value, a lower value besides 0, it'll take longer to get there, but your spirographs will be that much smoother, okay? So that's the gist of the machine. Let's go ahead and take a look at those and see how they work. Okay, so let's take a look at the manual spirograph machine, okay? So here are our controls. We can see the primary function, the secondary function, okay? Draw, what draw means is that it actually drops the right head down to the board and starts drawing, okay? Run is a little bit different. Run means it starts running a sequence. So a reason that you may want it to continue to run without drawing is if you're trying to let it warm up to a particular pattern. Like let's say you just changed it and you're doing a very small circle, well, there's going to be some travel time to get to the outside. So that's why you would raise the right head up, but let it continue running, okay? You can accomplish that in the state machine programmable one by adding delay, and we'll get to that later. Color lets you set the color, and erase wipes off the board, okay? Over here are your little charts so that you can remember if you forget like what function 1 is, you can see that's a sine wave, and then here is your color decoder, right? So if I want to draw like purple, I can put in color 6 there, and then this readout here shows you what you have the machine configured for. Okay, you will have to use your maker pen to configure this. There's quite a wide range of number values that you can have in here, and it would be pretty hectic on there if you wanted to have buttons to configure everything, especially since your buttons, your like RPMs can range from like 0 to 99, right? So this would just be a lot of button pushing. So you will need to use your maker pen, but it's not too bad, right? So what you'll do, for example, is you'll click on this variable chip, and I can see, let's see here, that rotator 1 is set at 60 RPMs, right? So I'm going to slow that way down. I want it to go, let's have it do like 5 RPMs. And actually what I'm going to do for this, just so it's not too complex, I'm going to lock rotator 2. So I'm going to put that to 0, okay? So let's start, let me clear this off here. Maybe we can see that's getting erased. And let's set our functions. So yeah, let's just start drawing here. And what you'll see is when I hit draw, the right head comes down and the seconds start incrementing. And that is so when you go over to the programmable machine, you can remember how much time you needed for it to draw one cycle, so you can set that. So that was about 12 seconds, right? We're going to stop that. And then let's say I want to make like another circle inside of that, right? I can just drop the amplitude down. So amplitude, you can see, is the red pin on here. So let's drop that down to 15 and let's draw. There you go. I got another circle inside of this circle that is 2 centimeters inside of that. All right. Another 12-second cycle there. Okay, so that's done. So let's do something a little bit more interesting now. Okay, so let's set the secondary to a sine function. Okay, so you can see now it's starting to zigzag a little bit. So it's going to stay at 19 because we haven't unlocked the primary yet. Let's increase the size of the secondary's amplitude so you can see what that looks like. So right now, amplitude is coming off the red pin, so it's at 15. Let's bump this up to like 20. There we go. And let's get a different color going here. Maybe we can do some orange. That's good. And let's draw with that. Okay. So let's bring the primary in a little bit. We want to get more into the center, right? So primary, we're going to set your amplitude down to like 12. And what you'll see now is like, see how that's drifted inside, right? And then secondary, I'll tell you what, let's bring the secondary back to 0. Okay, but we're going to turn on the rotation. Okay, so we're going to configure that through here. So let's bring the rotation on for this. So what we're going to see now is this is going to start spinning in circles. So let's see what that looks like, and let's get that yellow. Okay, and let's start drawing. Yes, we're getting some nice big circles on there. This is starting to look like probably more what you used to from an actual Spirograph machine, right? And obviously we don't have to run it at this slow speed. We could speed it up, but I'm just going to go ahead and let this thing run at this speed. It's a little easier to kind of put together in your head what this thing is actually doing if you're just kind of looking at it running a little slower, because obviously if the thing is just going as fast as it possibly can, it's a little tough to understand. So man, I really like that. It's a nice pattern. Kind of looks like like rose petals almost. You know, I like that a lot. So let's just wait until it comes back to the starting point. We should be almost there. It's looking pretty even. And there it is. So that was a 60-second pattern. Okay. So if I wanted to, let's say maybe have more lines than that, right? Now, let's see what we can do about that. Let's set our rotation speed up on our secondary a little bit higher because it's just doing 1 right now. Let's bring that up to 4. And let's get a different color. What should we get in there? How about some pink? That's 9. Let's go for that one. And you know, actually, I think I want to let's bring it down to the inside a little bit more. Okay, so let's reduce the amplitude on this. So I'm whenever I say I'm reducing this, so I'm looking at the lower spirograph does the second, or the lower spiral controller does the secondary, the upper one does the primary, and this guy over here does the RPMs for both of them. So I want to reduce the amplitude, which is going to make these circles much smaller. So let's drop that down to 10. Okay, and you can see here, you see these beacons? So what these beacons are telling you, the one in the center is on the primary rotator, this other green one is on the secondary rotator, and these two are part of the right head, right? Let's bring this guy up a little bit, the primary, so that I'm not writing into the center. Maybe a little overlap. I kind of like this. All right, let's draw that. All right. See how many times it takes to make a complete cycle. Now you could obviously go through and do the math and figure out if you want like a very specific pattern, how many times it's going to go and actually take to complete that cycle. When I say complete, I mean, see how there's a gap right there? This will eventually come back when the frequency and the rotation line up so that it writes over itself and then it's repeating, which means you won't have just a random start and end of a line there, which is something you probably don't want in your spirographs. I think that looks kind of ugly. All right, let's just give it a few more seconds. Should be done. You can see how it's getting nice and uniform now, and that point is right there. So we just completed another 60-second cycle. Okay, so I think that's enough playing with the manual spirograph. I'm not going to show you how to do like every single pattern in the world. Let's say that you were good with this and you want to go ahead and remove this from the machine, so you can hit stop on the run, and then you want to clone this. Don't try to like lift it off the board because it's wired in there. So clone this and then slide it. Unable to clone square. Okay, come on. There we go. I don't know what it was complaining about the first time. There you go. Now the neat thing in this room is you have Maker Pen access. You have the ability to create inventions, so you can go ahead and take this. If you want to use that in your dorm room, you can do that. You can make inventions out of it and put them up on the invention store. I'm just going to scale this up a little bit where I have some light. And one thing you'll notice too, like now that I have that art canvas, like the resolution on this is much better if you compare it to like the old ones. They're very pixelated when they're blown up. So yeah, thank you Rec Room, because that looks way nicer. Okay, so let's talk about the programmable Spirograph machine. Okay, so what this thing does that's really cool. Remember how I said like this one, there's kind of like a lot of configuring. This one has a language that takes all the manual controls and encodes that into the variables inside a state machine. So that sounds complex, right? Like, why would you ever want to do something like that? It's because you have the ability to basically create a program that generates a spirograph and then tweak it. So you could say, I like that thing that I just made, but I really want to change the color scheme. I don't like the pink that was in there. Or I want to change the amplitude on something just ever so slightly, right? Or I like what I did, but I want to take the middle layer out and bring that up to the top. I want the yellow, for example, to be on top of the pink layer, right? So you can do that by programming these state machines and then changing the order of them. And this machine will help you to program this machine. So the last sequence that I did over here was this pink layer. So let's see what I need to do to create something like that, right? So I'm just going to grab a state machine state, and let's configure this thing, okay? To do that, there is a little decoder over here that tells you what the variables in the state machine, what they mean for this machine, how it interprets it. So I can see that in variable 1, the first 2 positions are the RPMs of the primary. The second or third position, is the function. 4th and 5th are amplitude, and 6th and 7 are frequency. Same thing for the secondary, and then down here is smoothing factor, delay, and color. So smoothing factor is basically it sets how fast the pistons make it to the next pattern. So if your smoothing factor is set to 1, which most of them are going to be set at, you probably don't even need to bother changing that. It gives it a little bit of travel time, but the reason you need to be aware of that is if you are changing pattern, you'll want to introduce some delay. Now we could do that over in that machine by raising the write head and letting it get into that pattern, but with this, since we're not manually intervening with this thing, you can build delay in and tell it, okay, I want you to run a 62-second pattern instead of a 60-second pattern, and I want you to delay for 2 seconds to let the machine acclimate to that new pattern that'll be running, right? And then color is just the color. So the really nice thing about this is if I want to run the same pattern and then just change the color, I just have to go change that last number, right? So that means anything that you see around this room that has state machines, state chips on it, you can go and take this and say, I want to remake this with different colors. And you can just take those chips over there and wire them up to the state machine programmable Spirograph and change the values, and you can change the color scheme, change the amplitude, all that kind of stuff, right? That also means that any work that you're doing in this room, you can save your work, you can take those and make an invention out of them and come back later. You don't have to sit here and jam on this machine for like 2 hours and feel like you can't leave until your work is done. This allows you to save and come back later. So this is kind of a really neat tool. I hope people will come and give this thing a shot. Okay, so like I said, let's get this pink pattern in here. So we said, let's see here, configure. So min, time, and state, we're going to set this for 62 seconds because we did a 60-second run over there, right? So our RPMs on the primary was set to 5. And remember, everything is 0 padded, okay? The first one doesn't matter, but let's just put it in like that anyway. So 0, 5, okay, on the primary, that's the rotator. Next one was our function. Function is 0. Amplitude is 15. And frequency is 10. Technically, frequency doesn't matter when you have a static, but I'm just going to put it in there too, okay? So let's do the secondary now, okay? So RPMs are 4, so 04. F of x is 0, that's our function. Amplitude of 10. And this guy was 0, 5. Remember that 0 is important, otherwise things won't line up, right? Now, our color, we did pink, and let's see, our smoothing factor is going to be 1, right? Smoothing factor of 1, delay of 2, and then our color is going to be 9 for pink. Okay? So now that we've coded this, remember what we're going to try to do is make this pink pattern. So what we're going to see over here is lots and lots of circles, pretty tightly overlapping, okay? So the way that you do this is, see this connect to me, you connect to that, okay? Don't connect to the start or the thing will just start running, okay? And then I'm going to disconnect these right now because I'm not working on those. And then I'm going to make this go back to start. If you forget to do this, it'll get stuck in this state and it will just keep running, okay? Let's clear the work off that we have on the table right now. Give that a second. There we go. All right, let's start this thing up. We'll see it start spinning, okay? And now it started right after a 2-second delay. So you can see the time up there, and I can see the program it's running, right? It's running 5 on the primary, 4 on the secondary for RPMs, right? Which matches up with over there. Everything matches up, 0, 15, 10, 0, 15, 10, 0, 10, 5, 0, 10, 5, smoothing factor of 100, delay of 2, and color 9. So we can see, right, we're looking at this thing and we're saying, man, this is looking pretty good. It's looking pretty much exactly like what I had over there before. And if I wanted to, I could go and, as I was doing those states over there, I could have just made a state chip if I liked what I saw, and I could have recreated that entire thing that I did on the manual. Or I could have said, you know what, I don't like this one layer. I'm not gonna build that in here. It's up to you. So these two machines, again, like you can stick entirely with the manual machine if you want, or you can use the manual machine as a way to make a program for the automated machine. So that looks pretty complete. There we go. Look at that. Man, that is beautiful. So let me clone this. Come on. There we go. And let's take it over here. We'll see how we did. Scale it up. The other one's kind of intersecting with it. Let's go this way. All right. So yeah, I'm pretty happy with how that came out. You can see the pattern is pretty much exactly what we ran on the manual one. All right, folks. Well, that's it for Spirography. I hope you come check it out, make some cool stuff, and have fun playing Rec Room. See ya.